Hello, good morning students, and welcome back once again to the new video of the class 10 light chapter and the exercise portion. And today I have more questions from you from the exercise for you. And the first question is, which of the following lenses would you prefer to use while reading the small letters? Okay, so as a magnifying lens, so if you are using a dictionary or something, if you require a magnifying lens, which kind of mirror lens would you use? So the first option is convex lens of focal length 50 centimeters. So 50 centimeters, okay. So imagine you have a scale that is as long as 50 centimeters. I have a normal scale over here, and the maximum it has is 30 centimeter over here. Add another 20 centimeters, that means somewhere over here. So the scale is going to be really large, and if the focal length is that big, you know that we can get an erect image in a convex lens, okay, but it should be less than the focal length. So that means this is a very long distance. You will get a magnified image, but you might not be able to see it because you would require a lens that big. You would require a lens that would have what you can say, the radius or the diameter that big. Aperture should be much larger to observe the objects. So instead we use a convex lens that is having a smaller focal length. For example, this has the option, the last option is, the third option is convex lens of focal length 5 centimeters. So as you can see, 5 centimeters is quite a small distance, this much only, and then you use that distance over here like this, and when you observe from a distance less than 5 centimeter in your magnifying lens, you will see the letters to be much larger than before. Understood? So we require a convex lens in which we get an erect image, and that too on the same side of the object. That means if you remember the last case of the convex lens, that is the erect image. So look at this one, and this is our convex lens, and we place the object over here like this, okay, and we get an erect image somewhat like this. So you are observing from this side, you are observing the letters from this side, and this letter that you see on the dictionary or any small letters on the book, then it appears to be this much larger, okay. So the object is this one and the image is this one. So magnifying lens is used for observing the small letters or objects with the smaller focal length. So this is the focal length, let's say this is the 5 centimeters focal length, just 5 centimeters. Then you can see that the object is much larger than before. That is why if it is 50 centimeters, it's not a problem, but the image distance and the object distance will not be that much, and it won't be that much clearer for us to see the larger objects. Okay, so the answer is C, that is the convex lens of focal length 5 centimeters. Here obviously in the first option, that is convex lens of focal length 50 centimeter, you will still see the object, but it won't be as much larger. So in order to get a larger image, you should use the focal length less, that is the 5 centimeters. So you would require a convex lens of focal length 5 centimeters. Okay, concave lens of 50 and concave lens of 5 centimeter doesn't matter, because in concave lens it is a diverging lens, and that is why it is always going to give us a diminished image. So that is out of the question. So we only had the confusion between convex lens of 50 centimeter and 5 centimeter. Okay. Moving on to the next question. We wish to obtain an erect image, okay, using a concave mirror. So concave mirror is a converging mirror. Which one? This one, okay, concave mirror of focal length 15 centimeter. What should be the position of the object? So we wish to find the erect image, and what should be the position of the object. Once again, if it is a converging mirror or a converging lens, if we wish to obtain an erect image, it is always going to be virtual, that is behind the mirror. So somewhere over here like this, and the focal length is given as 15 centimeters. So I am drawing the rough diagram over here for you to get the idea. So if this is the focal length, the object should be between focus and pole in order to get the virtual and erect image. Okay, and the next question is, draw a ray diagram for it and write the nature of image. Write nature of image. So the first answer that you will write is that the position of object should be less than position of object should be less than 15 centimeter, less than 15 centimeters from pole or mirror. From pole or mirror, it should be between focus and pole of mirror. So this is your answer. The object should be placed between the focus and pole of mirror. Okay students, I hope it is clear to you. Now the next part is, what is the nature of the object? So nature of the image. So image is virtual and erect. So nature of image is that it will be virtual, erect and enlarged image. It will be virtual, erect and enlarged image. Virtual means it will be only inside the mirror. Okay, you cannot project it on a screen. I hope it is clear to you students. Now in order to draw the diagram, it is quite simple. Now whenever it is asked in the question to draw the ray diagram, it should be quite perfect, neat and clean diagram. So the first thing that you should do is draw the principal axis like this. Okay, after drawing the principal axis, you can draw the mirror. But look at the question. We know that we are talking about virtual image, correct? So virtual image should be behind the mirror. So first of all, you need to keep the mirror in the center so that you have enough space for drawing the image behind. So I am drawing the mirror somewhere over here like this. Okay, and then the focal length is given to be 15 centimeters. Okay, but you are not supposed to draw the accurate ray diagram. If in the question it is asked draw the accurate ray diagram, you can do that. I am taking the half of it, that is 15's half is 7.5. So I am taking 7.5 over here and I am writing focus over here. This is the pole and I can keep the object anywhere like this. I am keeping the object over here. So the first thing is, you take the parallel ray of light. Whenever it is parallel, it passes through focus. So after reflection, it will pass through focus like this. So it is going this way. Okay students, so I am taking parallel. After reflection, it is going through focus. The second one I am taking through pole, and whenever we are taking through pole, we know that it is going to create angle of incidence and angle of reflection. So like this. Okay, so one ray of light going this way and this way. Now because they are these rays of light are going far away, we have to take the projection behind the mirror like this. So this one I am taking over here like this. And this one over here like this. These two rays of light virtually meet behind the mirror at this point, and this is where my image will be. And as you can see, this is the object and this is the image, and it is enlarged, and obviously it is behind the mirror, so it is virtual. I hope it is clear to you students. Moving on to the next question. Okay students, so the next question is, name the type of mirror used for. So the first one is headlight of a car. So if you have seen any vehicle, not just a car, even in the motorcycles, you might have seen that there is a bulb and there is a small silver coated covering behind, that is sort of a mirror. So why do they keep that? It's because that whenever there is a bulb kept over here, all the rays of light, they pass through like this, okay, and after reflection they go in a straight parallel manner, so that wherever the rays are going, they create a high beam of light, which is very necessary for us while driving at the night, because if single bulb is used, then its throw will not be as powerful as this one. And not just for the vehicles, even for the flashlight that you use at home, okay, a normal flashlight, you put two cells in it and then it works perfectly, because the bulb itself is very small, okay, it does not have that much power or intensity of the light. But when you cover it like this, it throws all the rays of light in one particular direction, and because of that we get a powerful beam of light, because the rays of light do not scatter away, they are all focused and going in the same line. And that is why the mirror used in this one is a concave mirror. Which one is it? It is a concave mirror, because when the ray of light is going from focus, it becomes parallel, we know that, and when it is parallel, it goes through focus. Okay, so the first answer is concave mirror. The second one, side view or rear view mirror. So you have seen that whenever you see in a side view or the rear view mirror of a vehicle, you always see that the vehicles behind us appear to be smaller, and when it appears to be erect, it is not inverted and it is smaller, and you get a wide range of view, everything around you. And that is why the mirror used in this one is convex mirror. Why? Because in convex mirror we always get a smaller and diminished image, and it is always erect image. Because if we are using a plain mirror and if we have a very large vehicle behind us, then we might not be able to see the distance or the object properly, because the plain mirror gives us the exact same size, okay. So if the convex mirror is used, then it will give us a smaller image of the object like this, and it will be easily readable for us to that whichever vehicle is coming from behind, and understand, and we can maneuver the traffic along with that. Okay students, so that is for the second one we are having convex mirror. For the first one we have concave, second one we have convex. The third one is solar furnace. Okay, so solar furnaces are the furnaces which use to you can say melt objects or create something like solar cooker and everything, but with the help of solar energy. And once again, for this, as you know that sun's rays of light are coming in parallel to us like this, and they all get focused at one single point. This is our focus point, and thus once again for solar furnace we are using concave mirror, so that all the light is focused at this particular point. So if you are using it as a melting furnace, then you place the object over here, and sun's light and heat energy will be focused on this point, that is our actual focus point, and then the object will melt. Or if we are cooking the object in solar cookers, then once again this will cook the object very quickly, because we are keeping it at the focus point. All the light and heat energy is focused on one point. I hope it is clear to you students. The next is, one half of the convex lens is covered with black paper. Will this produce complete image of the object? Verify your answer experimentally. Okay, so they are saying that one side of the convex lens is covered with black paper, so the light cannot pass through this part, and we are keeping the object over here, and we want the image over here. Let's say that we are keeping it on 2f, so the object is passing, light is passing through this and going this way, and the other ray of light we are passing over here. As you can see, it is just touching the optical center, not pole. This is the optical center of the lens, and because this is just touching the optical center of the lens, then all this black paper does not mean anything to us, the light will completely pass through it and the image will be formed. However, not all the light passing through this lens will reach over here, and that is why the image will be less brighter. Okay, if this black paper is removed, then the image will be very sharp and bright. It will be very sharp and bright, but because we have placed black paper over here, the light passing through will be less, and therefore the image will be still sharp, but it will not be as bright as before. Okay, so this is how you can prove that the object's image can be formed easily using a convex lens if you cover it half with black paper. It doesn't matter. Okay students, so that's all for today, and we'll talk more about in the next video. Till then, have a nice day.